Okay, so now let's say you understand how the calculator operates.
Yes.
Okay, so now if you still remember in a calculator, you're going to put something inside the calculator, right? Or you can say 2 plus 2, then you get an output of 4. You understand?
Yes.
That's exactly what we refer to as a function. So a function is a rule by means of which each element of the domain. Ne? So the domain is your dependent variable, or you can just call this the input. That's the value of x. Ne?
Yes.
And then it's going to be associated with what? One and only one. So the one and only one is very important. It should be one and only one element of the range. Then the range, that's what we call your dependent variable. And then you can also call that the output, which are the y values. Are you happy with that?
Yes.
Okay. So now we can represent functions in different ways. For example, I can say y is equals to 2x minus 3. So this is a function. I'm not sure if you agree with me on that, but this is definitely a function, right?
Yes.
100%. So now, uh, so when I say 2x minus 3, that's a function. And what type of a function is this? This is a linear This is a linear function. It's a linear function. But when I say y is equals to 2x squared plus 1, this is a quadratic function. Tell me, how do we see that this is a quadratic function?
Mm, when it has the power to.
Exactly. That's very correct. Right. So since we are covering the basics of functions, there are some of the things that you need to understand on the basics. Ne?
Yes.
Uh, okay, so when we cover the basics, please listen to this. Ne? Let's say we give you g at x, and we say that your g at x is equals to 3x squared minus 5x. So this is the given function. From this given function, we're going to answer the following questions, okay? So this is your g at x. This is the given function, and we need to answer the following questions. First thing first, you need to be able to find g at 1. If they say find g at minus 1, what are you going to do? What will this be equals to?
Um. Oh, would we substitute the x with one?
Exactly, with minus 1. So this will be 3. Where there's x, we put minus 1. And then where there's x, you keep on putting minus 1. And that's it. So now if you look at this, you just have to punch this on the calculator. 1 squared minus 1 squared is just 3. Minus negative, and a negative is positive. That will be plus 5, which is 8. Are you happy with that one?
Yes.
But what is g at x is equals to 2? When it's given like this and they want you to determine this, determine g at x is equals to 2. Already you know what is your g at x, right? It's 3x squared minus 5x. And then you take this guy, you substitute, you equate it to what? To 2, and then you solve for x. You see? So they just want you to determine this, the values of x. You just have to uh, solve for x from this guy. You just have to solve for x. So solving for x, this will be 3x squared minus 5x. The 2 comes to the other side to be negative. We equate this to 0. So I'm not sure if you still remember how to factorize quadratic functions.
Yes, I do so, but
So now
I
remember,
don't.
if we have this the value of a as 3, how can we factorize this? Do you know how we can
Oh,
factorize this?
um, using a calculator?
Uh, Remember, since you are in grade 10, you can't use the quadratic equation yet. Oh, unless if you are doing IB. But let me let me give you a tip how to go about this. Né? You see the first 3x squared. You're gonna write the 3x this side. You put the x on the other side so that when you multiply these two, they give us 3x squared. You understand?
Yes,
Okay. Then you're going to take the minus 2. You see this minus 2,
yes,
the minus 2. You need to find the factors of 2, right? And the factors of 2 is just 1 and 2. So between these two factors, you need to choose where are you going to put the 1 and where are you going to put the 2. For example, let's say that we choose to put 1 this side, and then you're going to take the 3x, you multiply that with 1. What do you get? What is 3x times 1 is just 3x. You compare the answer with that 5x. So the first one we get 3x, right? And then you're going to check what happens if you put the 2 this side. Then you take the 2, you multiply it with the 3x, it gives us 6x. You're going to choose between these two. The one that is close to 5x is the one that you'll choose. So 3x, it's not exactly close because after 3x, there's still 4. And then, but 6x is next to 5x. So the correct one, we need to put 2 this side and then 1 on that other side. I'm not sure if this makes sense.
yes, sir.
You understand how this works?
Yes,
So this bracket will have 2. Then the other bracket will have 1. Then that's when you decide which side is positive, which side is negative. So we need this 6x to be negative so that when we add that x, the plus 1x, when we add this, we get minus. So this guy should be negative, this one should be positive. Meaning that this equation, if we continue, this is just 3x plus 1, close the bracket, into x minus 2. This is 0. When you solve for x, we can now use the zero product property. So this will be 3x plus 1, equate this to 0, or you take the x minus 2, equate it to 0. When you solve, the 1 comes to the other side to be minus, divide both sides by 3. Then you're gonna have your x to be minus 1 over 3, or the value of x is just the 2 comes to the other side, which is 2. Are you still with me?
so
All good.
yes.
Okay, so now that's how you solve functions. So now sometimes they might want you to find they might want you to determine, maybe they'll say g at 3 minus g at minus 2. So when it's like this, remember your g at x, it was given as 3x squared minus 5x. So now what you're going to do, you need to first find g at 3, where there's x, substitute that 3. Then you'll get the answer. You do the same, you find g at minus 2, where there's x, put that minus 2. Then you find the answer. So I need you to help me with the calculator. What do you get? What is 3 into 3 squared minus 5 into 3?
Sir, I'm coming.
You got? What is the answer for this one?
Sir, my calculator is not here.
Okay. Uh, okay, it's fine. So now what we're going to do is that we can definitely punch this on the calculator. Let me do this on my side.
Thank you, sir.
Okay. So we have 3 into 3 to the power 3, squared. Then this is minus 5 into 3. Close the bracket. This gives us 12. So the top part is 12. Then we separate this by minus 2. Then this is also minus 2. So this gives us 22. 22. Okay. So now the top part is 12. The bottom part is 22. So remember, we are looking for g at 3, which is 12. Then you subtract g at minus 2, which is 22. And then your answer is just negative 10. You understand that part?
Yes, sir.
Okay. Right. Now that you understand the introduction to functions, let's move to the next part of functions. So the next part that I want us to discuss is what we call linear functions. If you don't want to say linear, you can say a straight line graph. Right. You can say a straight line graph. Okay. So now, remember the standard form is y is equals to mx plus c, or the standard form you can write it as y is equals to ax plus q. Tell me, did you do this at school?
Yes, we did y equals mx plus c.
Okay, this one.
Yes, we did that one.
Okay, so from this equation, what you need to understand is that the m is the same as a in these two equations. A and m is the same, and we call them the gradient. And if you don't want to say the gradient, you can say the slope of the graph. So what you need to understand is how the gradient works. So if the value of a is greater than 0, meaning it is positive, and the value of m is positive, this is how your straight line graph will look like. So look at this. This is how the straight line graph will look like. So this will be a straight line graph. Okay. And let's say the value of m is less than 0, meaning it's negative. This is how your straight line graph will look like. Okay. It will be a decreasing function. So why are we saying that this is a decreasing function? Do you know why is it a decreasing function?
Because the arrow, sorry, the gradient is going over the negative side.
Okay, you know what? This is the best way to interpret this. Look at this. This is you. You're going to move left to right, always moving left to right. Can you see that? For this one, for this graph, the moment you get to that point, you start moving up. Can you see?
Yes.
That's why we are saying this is a positive gradient. You are moving up, meaning it's an increasing function. So you are increasing. Okay? Then,
Yes.
if you start moving left to right, can you see that in this point you'll be moving down because the slope is negative? Then we call this one a decreasing function. Okay?
Yes.
So it's very important that you understand how to calculate that gradient. You need to have 2 points to find the gradient. Then you find the change in y and the change in x. So it's the change in y over the change in x, and that value of c there, the value of c from this graph, that's your y-intercept if x is 0. So y is equal to mx plus c. We are saying that this c is the y-intercept of the graph. Okay, everything will make sense now. Okay, so now when you look at this, when you look at this, I need us to go through this two graphs to determine the domain and the range for these two graphs, the domain and the range. Do you understand what is, do you know what is a domain? What is a range?
I've heard of the concept, but I don't really know the definition.
Oh, okay. So when they ask you for domain, the examiner is asking you which x values can your graph take. You understand?
Yes.
So if you look at this graph, it takes all the arrow, it shows that the graph keeps going down, but it takes all the negative values and all the positive values. That's the domain. So meaning the domain of the straight line graph will always be x. It's an element of real numbers. Always. Domain, it goes with x. The range, it goes with y. The range goes with y. Okay, so now when I look at this graph that we have here, when they want you to find the range, it's like we are asking you which y values can your graph take. Look at this. It takes all the positive and negative y values. So same, y must be an element of real numbers. The domain will always be like this. Okay? You
Yes.
understand?
Yes.
Okay. So now, since I'm starting term 3 with you, we're going to have a lot of work to do, okay?
Yes.
Yeah, we're going to have a lot of work to do. So in most cases, when you have an equation like this, okay, an equation like this is a straight line equation. So how do we find the equation? How do we find the equation of a straight line function? How do we find the equation of a straight line? Okay, so we have 3 ways that you can find the equation. The first one is when you are given 2 coordinates. When you are given 2 coordinates, this is how you'll find the gradient. You find the change in y over the change in x. That's the first one. Right. So number 2, sometimes we'll have 2 functions f that is parallel to function g. So if you have 2 functions that are parallel to each other, just know that you'll be given the gradient of the first function and the gradient of the first function is equal to the gradient of the second function. Very important. If 2 graphs are parallel, they will have equal gradients. You understand that?
Yes.
Okay, 100. Now, let's say you have 2 functions that are perpendicular. Function f, let's say it's perpendicular to function g, meaning that when you multiply the two gradients, the gradient of, if you multiply the gradient of f and g, you need to get their product as -1. So the gradient of the first function multiplied by the gradient of the second function, this will be -1. Okay, so this is also some of the important information that you need to master. This is the first one. If you are given 2 points, this is when you are given equations that are parallel, lines that are parallel. This one is when you are given the lines that are perpendicular. Okay? Are you still with me?
Yes.
Okay. Now, let's say we need to determine the equation of a line, of a straight line, that is passing through 2 points, -1 and 4, and -1 and -2. So this is 2 point, this will be point A, and this will be point B. Let's say you want to find the equation of the line AB. We need to find the equation of the line AB. Remember, first thing first, find the gradient. The gradient is y2 minus y1 over x2 minus x1. What should we do? We need to name our points. The first point, it will be x1, y1. The second point, it will be x2, y2. Then, you see, when you named your point, it's going to be easy for you to do the substitution. You understand?
Yes.
Okay. So to do the substitution, this will be -2 minus what is y1? 4. Then divide by what is this? X2, that's -1. Then minus into -1. So the top part is -6 over 0. So remember, any number divided by 0, it's undefined. So the gradient is undefined.
Yes.
Listen, if you try to calculate the gradient and you find that your gradient is undefined, this means that the graph is what? Therefore, the graph is a vertical line graph. The graph will be a vertical line graph, meaning it will look like this. It's just a vertical. It will be, meaning it is parallel to the y-axis. Let's try and plot that graph. Do you understand?
Yes.
So when you plot that graph, we're going to say it's a vertical line. So you're going to look at the x values of that line AB. Look at this. So when you look at the x values, x1, that's -1, x2, that's -1. So therefore, the graph will have x is equal to -1, which is your vertical line. Then you can definitely plot your graph. So it won't have a slope. It doesn't have a gradient. This will be your x, this will be your y. Then your graph will go like this. We said x is -1. So the graph will go at -1, which is this side. So your graph will go like this. This is your straight line graph. I think it's best if we indicated that with a different marker. So this is the graph. So this graph here is the graph of x, it's equal to -1. It cuts at -1. I'm not sure if this makes sense.
Yes.
Okay, right. So now let's try and determine the equation. Okay, so let's say we need to work on this one. So determine the equation of straight line that is passing through -1, and let's say it's perpendicular to x minus 4y, which is 4. You see, this question, it needs attention. Right? You need to analyze the question. The straight line is passing through this point, but it is perpendicular to this. So you are given one point. There's no way that you can calculate gradient. So to calculate gradient, you need to use the given equation. Do you understand?
Yes.
But we have a serious problem here. The given equation, it is not in standard form. When we say the equation in standard form, y should be subject of the formula. That's why you need to start. You need to take the given equation, make it subject of the formula. Do you want to try and do that?
No.
No. Let's work on it together. Eh?
Yes.
Right. So now listen. Look at this. Né? From this given equation, I'm going to take this equation. I'm going to make y subject of the formula, meaning that I'm going to isolate everything and leave y on its side. So let's first take the x to the other side. So it will be negative. So minus 4y, it's equals to 4 minus x. Then we're going to divide every term by -4 because I only need y. Every term by -4. This 2 cancels. I'm left with y. It's equals to 4 over -4. That's -1. Negative and a negative, that's positive. Therefore, this is just 1 over 4x. So if I rewrite the equation, the standard form is 1 over 4x minus 1. Do you understand how I got that one?
Yes.
Do you understand where is the 1 over 4x coming from?
Yes.
Okay, right. If you look at this part here, that's like x over 4, which can be written as 1 over 4 times x over 1, which is just the same as 1 over 4 times x. So when it's in this form, it is in the form of y is equals to mx plus c. So tell me, what is the gradient of this equation?
1 over 4x minus 1.
Wait, what is the gradient? Because remember, the gradient is the coefficient of x. What is the gradient? Compare
1 over
this.
4.
Exactly. So let's call this the gradient of the first function, which is f. It's 1 over 4. They said these two guys are perpendicular. If two graphs are perpendicular, the graph of f multiplied by the graph of g, they should give us -1. Already we have this, which is 1 over 4. We multiply this by the gradient of g, which is -1. So therefore, to make g subject of the formula, I can multiply this side by 4, multiply the other side by 4. Therefore, the gradient of g, this will cancel, and then it is just -4. I'm going to give you a tip, ne?
Yes.
The best way to do this. Please listen. There is a way that you can work out around this. So if the gradient of the first one is 1 over 4, just know that the gradient of the second equation, it will be the inverse of this with an opposite sign. So you're going to take this and flip it as to be 4 over 1. Then you change the sign from positive to negative, which is just -4. So the graph of this is -4, meaning the new graph will have y is equals to -4x plus c, because it is in the form of y is equals to mx plus c, where there's m, we sub in minus 4. The aim now is to find C. To find C, we use the point that is given because they said that this equation is passing through what? The equation is passing through -1 and -1, meaning that we can sub in that point and make C subject of the formula. So we can substitute we can sub in the -1 and the -1. This is your x, this is your y. Let's do the substitution. Where there's y from this equation, we're going to put -1, and where there's x, you put -1 plus c. This is -1, it's equals to 4. -4 times -1, that's 4. We add c. So the -4 comes this side, the 4 comes to the other side to be -4, which gives us c to be -5. So c is -5, therefore the equation will be y is equal to -4x -5. Is this making sense? Are you happy with that?
Yes.
Are you happy? You understand how this works?
Yes.
Right. Let's try and analyze this question. We'll also try to plot the question. So look at this. The gradient of this graph. What is the gradient? Tell me, what is the gradient?
-4x.
No, don't say x. The gradient is just m, which is in front of x.
Oh, yes, I see now.
So it's just -4. So the gradient, it's less than 0, meaning your graph is a decreasing function. It will look like this. Do you understand?
Yes.
Okay. You can also plot the graph. You are more than welcome to plot the graph. You can definitely plot this graph. Okay. So to plot the graph, we're going to say we have y is equals to -4x -5. First thing first, when you plot, you need to find the x-intercept and the y-intercept. So the x-intercept, we find it if y is 0. So where there's y on the equation, you put 0 and you solve for x. Bring the 5 to the other side, and this will be -4x. Divide both sides by -4. What is x equals to? So it's going to be 5 minus 5 over 4. That's the value of x. Then you can definitely find the y-intercept if x is 0. Meaning that on the equation, where there's x, you can just put 0 to find the corresponding y value. So this will be 0 minus 5, which gives us your y to be -5. You see, which gives us the coordinates to be y is just the coordinates will be 0, that's the x, and your y, that's -5. Then when we punch this on the calculator, you said you don't have your calculator with you, okay?
Yes.
Okay, no, it's fine. We can definitely say 5 divided by 4. That's 1.25, right? So this is x is equal to -1.25. Okay, so now this will be 1.25, which is negative. It corresponds with 0. And this one, this are your 2 points. Then you just have to go on your graph and plot the 2 points. This is your x, this is your y. Are you following?
Yes.
Okay, so 0 and -5, it's somewhere here. And then 0 and -1.2, it's somewhere here. Then your graph will look like this. You see? So I think you understand, you get the idea now?
Yes.
Right, so you can see that your graph is a decreasing function. That's how it works. So you need to understand how to work with these things, with these questions uh, separately, and also how to work with them when we have mixed functions, okay?
Yes.
Right. So now that you understand the straight line function, can we move to quadratic function?
Yes.
Okay. Okay. So the standard form for quadratic function, which is we call them the parabola, the parabola. So it is in the form y is equals to ax squared plus q, but the value of a must not be 0. So the value of a, it tells you about the shape. If a is greater than 0, your graph will be concave up. It will look like this. We say that it has a happy face. Let's say it has a happy face. Can you see this thing? It's smiling.
Yes.
But if the graph of a is less than 0, meaning it's negative, your graph should look down. Then we say that it has a sad face. Can you see this guy's angry?
Yes.
Right. Okay. So Q, it will tell you the y-intercept. Okay. Q will tell you the y-intercept, and uh, the turning point, the turning point. This is your turning point. This is your turning point. So the turning point, it's always 0 is to that q value. Whatever q that you are given, if you are given q as 5, your turning point will be 0 and 5. Okay?
Yes.
Let's talk about the domain. Always, the domain for this graph, its x must be an element of real numbers, and the range. So the domain is always like this, but we still need to discuss more about the range, okay?
Yes.
This is your graph. So you can see that this graph, it takes all positive and negative values. This graph also takes all positive and negative values, which makes the domain to be x must be an element of real numbers. Okay, what about the range? How will the range work? So the range, it depends on the value of a. So if a is greater than 0, your graph will be concave up. You remember, right?
Yes.
So the range will be y must be an element of, so this one here, this top graph that you see here, this one, it's a happy face, a is greater than 0. So the domain will be from this point. And if you remember, this point, it's P. So it takes from P going up, which makes the range to be 1. This will make the range to be y must be an element of, it takes from P, and P is included. So we're going to use a big bracket like this one to show that the value of P is included. So this will be P. It takes all the way to positive infinity. Then you use a small bracket for infinity. Right. So another thing, okay, if the value of A is less than 0, your graph is concave down, which is this part. So it's from this point going down. So the domain, what will be the domain? The range. It will take from that P. Remember, this is your P. So it will take from that P going down. So the range, its Y must be an element of, it starts from, you start with the small number. So negative infinity is the smallest. So this will be negative infinity all the way to P. So P must be included. Right. Another way to write this one, the first one, you can say y must be greater or equals to p. For this one, you can say y must be less than or equals to p. I'm not sure. Are you taking notes?
Yes.
Okay.
Sir,
I'm listening.
why do we use the big and small brackets for p and infinity?
Okay, let me definitely explain that part. Just give me a second.
Okay, that's true.
Yeah. So now if look at this, why do we use
Yes.
small and big bracket? Okay. So if I say y is greater than p, the answer will be like this. From p all the way to infinity. So the difference is greater or equals to. So this one is greater or equals to. So meaning that p is part of the solution. P is included. So this one, it means included. Okay. This one means not included. Do you understand?
Yes.
So when we write greater than, that's how you should write your answer. And this is not part of this, because look at this. P is part of the domain, the range. So it must
Yes.
be greater or equals to P. Do you understand that part?
Yes.
That's why we are including P, because it's part of the solution. Infinity, we don't know which number is this one, so we can't include infinity. Negative infinity, we can't include negative infinity. But P is part of the solution. You understand?
Yes.
Okay. Now, let's say that you are given, I'll just explain this, then we'll take it from this when we come back, okay?
Yes.
Let's say that uh, we work on finding the equation, right? So remember, we are, let's say, uh, I don't think it's best if we start with this one, because there are three different ways that we need to work on, and that's what we should start on our next lesson. So it's fine for today. Let's stop here.
Yes, sir.